In this video, I wish to look at space using single point perspective and relative sizes of objects in proportion. I've put up some old pictures that I have of artistic implements, tools that we use, but I want you to realize that the best tool that we can use in all cases is our brains. Like many subjects, the subject of art is difficult to discuss one specific topic at a time. There's a lot of overlap, so we go back and forth occasionally and we give previews of different things that we may not have gone over. So I'm going to start by asking a somewhat rhetorical question. My question is, what do these four figures have in common? Now, you may have answered that they all have a fine fashion sense, but that's really not what I'm getting at. These four figures have one thing in common. They are all the same height. As a matter of fact, they're all as tall as me, and they are all as tall as you. Even if I am not the same height as you, I have the same horizon. I have the same horizon as them, they all have the same horizon, and you share that horizon when you look at this picture because I chose where the horizon would be. That's the power of being the artist when you're using linear perspective. You choose the eye level. That's the same as the horizon. Now, let's look at some basic body proportions. The ancient Greeks decided that their heroic figures, the figures that they sculpted and made in their artwork, would be 8 heads tall. This is also very similar to common comic book proportions. What it does is it gives you heroes with small heads and really big bodies and muscles. Even today, artists usually use the height of the head as a measuring tool when trying to figure out the proportions of the body. What we need to remember is that heroic proportion is not normal, actual proportion. Human bodies are usually about 6.5 heads tall. So here's a figure that's 8 heads tall, and I put 8 heads off to the left, you can see. And then there's another one that's approximately 6 heads tall, which is much more normal. And normally heads are about half as wide as they are tall, and the heroic figure is normally 3 heads wide at the shoulders, where the normal figure is approximately 2 heads wide at the shoulders. And while proportions vary widely on faces, there's usually some very general basic proportions that we can use, and superimposing a grid upon the face shows us that the eyes are approximately the halfway point of the head. So now I have my paper, and if you'll notice on the left-hand side, I've put 6 half ovals for head heights, and each of those is 1 inch tall. And if I split the top one in half, which is the head, that would be eye level. So I have 1 inch equals 1 foot in this case. That scale only works on the edges, the top and the bottom of my picture. Nowhere towards the center will that work, because as things go back in space, they literally get smaller in linear perspective. So I'm going to use my ruler, and I measure it out on the sides, and I don't usually use a ruler for this, but in this case, the ruler is good for multiplying and dividing distances. So that's what I'm going to do with it here. I'm going to divide this in half and put my vanishing point at 5.5 inches from the edge, and then I'm going to draw 2 diagonal lines from the corners going up. This is going to be an interior shot, so the center of the picture will be a back wall, and these 2 lines will show me the edges of a floor. Now, I know that 1 inch equals 1 foot holds true for the edges, the top, and the bottom of my picture. So I am going to measure out 1 inch at a time along the bottom of the page, and this will equal 11 feet because the paper is 11 inches wide. I'm going to construct a grid of 1 foot squares, like linoleum squares, across the floor to start with so that I can place things on the floor more easily. So by lining up each of these little marks along the edge of the page with that same vanishing point over and over again, I get rays radiating from the vanishing point that are each 1 foot wide all the way back to infinity. They're actually 1 inch wide on the paper, but remember our scale is 1 inch equals 1 foot. Next, I'm going to decide how far back I want my wall, and I'm going to draw a diagonal across all the lines going from the corner line up to where I feel the bottom of the wall should be. This should be below the vanishing point because I'm always looking down at the floor, right? I'm going to use those lines then, and I'm going to break off the back wall right there. So that's where the wall will go up. And then I'm going to use this diagonal line to situate all of the lines going across on my grid coming forward. As the lines get wider down towards the bottom of the page, the lines that are going horizontally across them will get wider and wider width of the space in between them, and this will make the grid correct in single point perspective. I'm just finding where each of those lines is crossed by the diagonal that I drew, and I'll take that diagonal out later, but this will space those lines coming towards me. Next, I'm going to draw the back wall by putting 2 vertical lines up from the edges of my floor grid. So now I have walls. My question is going to be then, how high do I want to make my ceilings? The easy answer would be 11 feet, but that seems pretty tall, so I'm going to make 9-foot ceilings. To do that, I'm going to find 4.5 inches up on my figure on the side, and I'm going to draw a line from that point to the central vanishing point. This will give me the halfway point of my wall, and then I can just double that at any given point and call that 9 feet because 4.5 times 2 is 9. Next, I'm going to use my ruler as a ruler and take the measurement on the left side of the page from the top and move it over to the right so that I have the same wall on the other side, basically. I know that the edges of the paper are vertical and horizontal, so by making similar measurements and connecting the dots, I know that I can get vertical and horizontal lines by lining them up with the edges of the paper. Now, since I have a 9-foot wall, I want to break it into 9 equal parts. I know that 4.5 inches will do me every half an inch, so I'm just going to pull back and look for a place where I have 4.5 inches tall on the side, and then make a mark every half an inch. And if I then draw lines to the vanishing point, through those marks, I have now made lines on the wall that are 1 foot apart, just like I've done on the floor. And I'm just going to do one wall, just like I did the floor, and I will use those to triangulate anything else that I can on the page. Now I could either use a diagonal line going 9 lines over, or I can just take the measurements off the floor, which seems to be easier to me at the moment. If I just line them up and get my verticals vertical, unlike that last one that I had to erase. And now you can see I have a grid on the wall and I have a grid on the floor, and you can see back into this room which has nothing in it. So now I'm going to start putting things in this room. Darkened up the lines a bit here. We have everything in place. We have a grid on the floor and we have a grid on the wall. And I'm going to put in a table. Now I googled normal table heights and they said about 30 inches. Well, since I have 1 foot markers on the side, 30 inches is about 2.5 feet. So I made an X in the box between 2 and 3 feet to find the center. And then I took that center of that square over to the vanishing point to find the proper height. And then I traced that box down to the floor. I traced it across to find out where I'm going to put the feet and where I'm going to put the front. because wherever I place the feet on the floor, that is the proper height for that end of the table. The rest of it will work itself out later on. But I had to find where I was going to place the bottoms of the feet. To do that, I traced down the wall and then across the floor, the same squares all the way across. Now from the feet up to the top of this end of the table, closest to us, is where that tick mark is on the wall at 30 inches. And now I am constructing a box, and I'm drawing through the box to find the back end of the table. You'll notice that the sides of the table went straight back to the vanishing point. The back end I had to draw up from the floor, and I decided which box, which is basically 3 boxes back. It's a 36-inch long table, which is 3 feet, and I drew up from there to find the back corners. And now I'm putting in some of the details on the legs. Remember that the insides and the back legs need to go in as well. So I'm going to have to do a little bit of drawing through and around to get them just right and lined up with where they should be. This is one of those many cases where in linear perspective it's just as important what you draw as what you erase. Now I'm going to put in a chair, another foot along the floor, and I know from consulting Google that most chairs are about 18 inches tall, which is 1.5 feet. So once again, I had to find the center of one of the squares on the wall and then take that center back to the vanishing point, find the mark on the wall, and trace it across to find where the feet go and build it up from there. Next, I'm going to turn my attention to the wall and put something on there. I think I'll put in a door frame, and to do that, I'm going to take the height of the room, which is 9 feet, and then the height of a normal person is about 6 feet, so this is about 7.5 feet up. I just used the grid on the wall to place everything, and remember that the door jamb has some thickness to it, so you'll notice at the bottom that there's a little jog in, and I put a hallway outside with another door jamb out there, so there's another room beyond even. I think I'll put a poster on the wall over here. I just use the squares on the wall to figure out where things go. So at this point I'm using the grid, especially on this side over here, to put in things like circular bases on lamps, and I can put the lamp farther up. I can construct a cylinder on the top, or at least the top end of a cylinder, so that I can make a lamp. My grandparents had a lamp like this once upon a time in their house. It shines on the ceiling, and then you get the radiant light coming down from the lighter ceiling. Of course, the lamp has to be plugged in, and we probably should put in a wall switch. Once again, using that grid on the wall to gauge everything size-wise. While I'm at it, I'm going to put some crown molding across the top of the wall, and I put some molding at the bottom as well, just to give it a little bit of room character. Now, being right-handed, I've sort of neglected the right-hand wall here. I've done a lot on the left. I think I'm going to put a sofa in here. I'm going to go 7 feet long, 18 inches up for this box that people are going to be able to sit on. And I'm going to make it about 2 feet wide just to start with. And this is just where the cushions are going to go. And then I'm going to construct a back and some arms as separate boxes and meld them all together as I go along. Notice that I'm erasing little bits of things that I can see through, but I'm leaving other parts because I still need those measurements. As I put in each of these separate boxes, I'm going to start not differentiating between them by taking out the lines. I want to make sure that they sort of meld one into the other. At the same time, this is a very stiff-looking back and a very stiff-looking arm. It does not look comfortable. So I'm going to put in some surface lines along the edges and get it a little bit more raggedy, a little bit more comfortable, a little bit worn looking as I go along. And to do that, I don't use the ruler to put in all the lines. I put in surface lines over the top. And you may have noticed me drawing an X in the long rectangle on the back to find where the center button is going to go, and then I take the 2 rectangles formed by that and find the centers of those to find the other buttons, and that will show me also where I can divide it into cushions. If you look straight down from each of the buttons, that's where the cushions are. Now I'm putting in a rug, and I'm just doing that by looking at the squares on the floor and putting in a long rectangular blank space down below. Now I've decided that I want to put in a hanging light over the table, so I go up the wall where about the center of the table is, and then I come down right over the table to put in a cord of some type, and then I'm going to construct a cylinder here, give it a lampshade. Takes a little bit of doing, get everything just so. I think we've done this before, and then there's a cylinder and cord, and of course a small cylinder sort of cap at the top, hanging it from the ceiling. Give it some surface lines across the front edge, and it will look just like a lamp. Let's put in a window. Now I know that my vanishing point is on the horizon, which is my eye level, so I put the top of the window above that, and then I go about halfway down to the floor and I put in the bottom of the window, making long skinny rectangles, and I have a window. I'll do a little bit of neatening up on the corners to make it look like it has a sill and maybe a shade with a pull string, and we'll have a full-fledged window here. Then I'm going to take the top and bottom measurements of this window and move it over to the other wall and construct a window in perspective. And to do that, I'm going to use everything that I can, moving it over from the back wall to this side wall by finding the corner of the room and just taking those horizontal measurements over and making little notches on the wall. You can probably see them back there. Finding the center of this rectangle that I made as a window, and I can put in a window pane split in half at the top. I'm going to turn my attention to those floorboards, and I'm going to divide them in half so I have 6-inch wide floorboards. I'm just using my eyes to do this, and then I'm going to put them in at irregular lengths so that they don't all cut off at the same place. And I think I'm going to put some texture across the surface of things. Remember, surface line is one of our basic rules of perspective. Put a little coffee mug on the table. All of these details add to this room. Eventually, all of those squares on the wall and the floor are going to go away and be replaced by other things. But by putting in all the shading and the texture and everything else, we can create a picture that is very believable. This picture is believable because it is in human scale and proportion, because we started with a human proportion of approximately 6 feet tall and an eye level, which is our horizon, of about 5.5 feet tall. Now I'm going to do the same thing that I just did, but with an exterior view, but I'm going to put my horizon at about 3 inches from the bottom of the page, squaring it up so I get it nice and level. I put my horizon there, and this is going to force me to look up it more than I did in the last picture. It's still going to have a human scale because whenever I have doors, I'm going to make sure that they're the right size, and whenever I have different floors on buildings, we'll make sure they're the right size along with the windows and things. But I'm going to scale it where 3 inches is about 5.5 feet rather than having it as 5.5 inches being 5.5 feet. And that's only along the edges and the bottom and the top of this picture. So the first thing I did is I put in some sidewalk space, and I have a central road now going back in space, and I'm going to start putting some buildings. And to do that, I'm finding it easier to work from the outside in, so I'm going to make some floors here. Figure out the height of a floor. I look at the horizon and I double that from the ground of that building, and that makes about a floor. That's 5.5 feet times 2, which is about 11-foot tall floors. Not a bad size. 12 might be better, but I'm not going to get that picky. And then I'm going to take the measurements of one building and move them over to the next one, so you can see that I'm constructing the faces of boxes, basically, going down the street. I'm just doing box after box after box. I'm putting a little bit of space in between many of them so that I have little tiny alleyways. But I can also put duplexes in by not leaving any space between them, and there might just be a line there. And I'm making different height floors. You can see that the next building looks like it might have 3, and then the next one might have 2, and then I might have 1, a garage or something on the end. Each of these boxes has their own character. Each of these boxes has their own size, but they all have the same human scale. And that scale at this moment is based on the level of the horizon. It's based on the idea that we're standing on the ground. Next, I'm finding the center of this box, and I'm going to put a peaked roof on this building. I hope you remember that to find the center of any rectangle, whether it's straight at you or if it's in perspective, is to make an X from corner to corner. And then I can adjust that straight up and make a peaked roof fairly easily. Because when a rectangle is in perspective, there is more of it that you can see closer to you than there is farther from you. So the center of that rectangle visually is not going to be measured over and then divided by 2. It's going to be the center where that X crosses. And now I'm working with the sidewalk down here, making it turn a corner, trying to keep it horizontal as it goes around the building. And as I build up more and more building details, I'm going to not only put peaked roofs on some, but have flat roofs on others with some molding around the top to make it look like it was supposed to be that way. You never leave something just hanging if you can help it. Although in the distance, the lack of detail, you may not be able to put that in, and it would be just fine. But up close, you want to be able to show all of those things. I'm going to put a doorway in over here, and to find the top of the door, I go halfway between the floor marking and the horizon, and that's about where the top of the door should be. And then I look up at the upper floors, and I want to put the windows in about where a door would be on that level, but break them off about halfway up to the top of the window as well. So I'm going to put some shingles on this roof because it's closer and I can see details. But when things get farther away, the details fade out. That's part of our density. That's part of the contrast, and that's part of the level of detail that you can and can't see. Lining up doors along the street with the vanishing point in the distance allows them to be about the same size and allows them to remain looking like humans could use them. Remember that everything has some sort of mass and width. So while you might not see the width on the window frames back here, the door frames that are up close to you, you'll probably see in on them a little bit, which is, if you look at the top and the bottom of my door frames, you can see that there's just a little bit of a lip around the edge to show the width and the thickness of the walls. The first time you measure out windows and doors on a building might be a little difficult trying to figure out where things go, but if you use the vanishing point and you use the corners of the building to take your measurements from one side of the building to another, you can quite often use the measurements that you used on one building and just transfer them over to another by lining up the tops of the doorways all the way along, by lining up where the windows are on the buildings. They will look like they're the same scale, and at the same time you're not making as many measurements because you're using the measurements primarily from the building that you did before. Now I put these two pictures together because they're really very much the same thing. They're single point perspectives. We're using the horizon to figure out our heights and doing that in human scale. In this case, I didn't put a grid across the ground, although I could have. I didn't put a grid up the side, although I could have. It would be a little bit confusing at times. I'm just taking the measurements from one building to another, figuring out where things go in relationship to my horizon, and working over and over again on the same sort of boxes, whether they have peaked roofs or squared off roofs, or they're skyscrapers like this in the distance. They're all very human scale. They're based on the same concepts and principles and the same vanishing point throughout. The vanishing point has not moved on any of these. It's always the same, and that puts these streets and these buildings in perspective on a grid. None of the buildings are out of line. If you want to make them out of line, you can change your vanishing points from one building to another to another. Don't get them too far apart, but you can make your buildings out of line that way. If you want to line them all up, however, and get everything on a nice grid like this, use that single vanishing point and everything will line up. Now from this point on, I'm just going to speed it way up so you can see the details that I'm putting in, and then I'll finish this picture up. There's nothing new at this point. We are making boxes. Occasionally we'll make a cylinder. We use circles, we use cones, but mostly rectangles, finding the center of rectangles and putting in textures along things, especially things that are up close to us rather than the things that are far away, which will lack a lot of the detail that we have. And I'll put the bat signal in the sky just because it's cool. Now I've added some shading, some values to some surfaces, and some textures that I then fade out into the distance to give us a feeling of density of the objects closer to us. Remember that linear perspective is very powerful, but it is not the end all. In the end, you must use what you know along with your linear perspective. You must overlap, you must use surface placement, and you must use proportion if you want things to look like it's a human world.